we now discuss the solution of a problem from the section Differential Calculus. The problem is on the continuity and differentiability of a given function. This question has appeared in JEE Main examination held on 25th July 2021 in the second shift. The problem is, if f of x is equal to, it is defined as integral 0 to x of 5 plus mod of 1 minus t dt when x greater than 2, and f of x is equal to 5x plus 1 when x less than or equal to 2. The four options are given. Then what is true? And the four options are given. Option 1, fx is not continuous at x is equal to 2. Option 2, fx is not differentiable at x is equal to 1. Option 3, fx is continuous but not differentiable at x is equal to 2. Option 4, fx is everywhere differentiable. Let's now discuss the solution of the problem in detail. We have the given function, and let's look at our options. The option 2 says f of x is not differentiable at x is equal to 1. Let us see the differentiability of the function fx at x is equal to 1. So x is equal to 1 will lie in the here f of x is equal to 5x plus 1 when x less than or equal to 2. In this, x is equal to 1 will come. Note that f of x is equal to 5x plus 1 for all x belongs to the interval minus infinity to 2 closed. Now, it is a polynomial and it is differentiable everywhere in this interval. So, f prime x is equal to 5 for all x belongs to the interval minus infinity to 2 where 2 is closed. So, this says at x is equal to 1 f prime x exists. That is, it is differentiable at x is equal to 1. So, f of x is differentiable at x is equal to 1, and whereas option 2 says is not differentiable, therefore the option 2 is not true. Let us take the given function. F of x is equal to, when x greater than 2, it is defined as integral 0 to x 5 plus mod of 1 minus t dt, and that you represent as g of x. So, where g of x is equal to the integral 0 to x 5 plus mod of 1 minus t dt. Now, x is greater than 2 and the integration is from 0 to x. That means x varies between 0 to x where x is greater than 2. While varying so, x crosses 1 also. So, therefore, this is to be broken into two pieces, because 1 minus t when t crosses 1, mod of 1 minus t takes different values, and that is why we write it as integral 0 to 1 5 plus mod of 1 minus t dt from 1 to x integral 5 plus mod of 1 minus t dt when x greater than 2. Now, in the first integral, t varies from 0 to 1. T varies from 0 to 1, and thereby 1 minus t will be positive. 1 minus t will be positive. Therefore, mod of 1 minus t will be 1 minus t only. But whereas in the second integration, t starts from 1, goes up to x where x greater than 2, then 1 minus t will be negative, then mod of 1 minus t will be minus of 1 minus t. So that we write it as, so mod of 1 minus t is 1 minus t only. Here mod of 1 minus t is minus of 1 minus t. Now simplify. Integral 0 to 1, the first one is 6 minus t dt. Integral 1 to x, the second one is 4 plus t dt when x greater than 2. It's a simple integration, do it. And this is 6t minus t square by 2, where t varies from 0 to 1. And the second integral is 4t plus t square by 2, and the x and t varies from 1 to x. Substitute, and upper limit, that is 6 minus half, the lower one 0. For the upper, 4x plus x square by 2. For the lower, 4 plus 1 by 2 minus. Simplify. After simplification, we will get 1 plus 4x plus x square by 2. So your function f of x is equal to g of x when x greater than 2, where g of x is now computed and we have obtained as 1 plus 4x plus x square by 2. Therefore, f of x is equal to the first one, 1 plus 4x plus x square by 2 when x greater than 2, and it is 5x plus 1 when x less than or equal to 2. We continue in the next slide. We have that function. Now, we have already discussed about x is equal to 1. Now, by this definition of the function, we see if at all there is some trouble regarding continuity and differentiability, it will be only at x is equal to. Otherwise, it is a continuous function. This is also a continuous function. If at all there is the continuity breaks down here, then x is equal to 2, whether it is continuous or not. And moreover, x is equal to 2, and differentiability is to be discussed. Why? It is differentiable everywhere, except maybe x is equal to 2. We do not know. So that is the discussion. Now first we talk about the continuity at x is equal to 2. Continuity at x is equal to 2 means you compute the left hand limit, right hand limit at 2 and see whether they are equal or not. And if they are equal, they are continuous at x is equal to 2. Otherwise, it is not. So f of 2 minus means what? Left hand limit, that is this one. So limit x tends to 2, left hand means 5x plus 1, and 5x plus 1 is what? It is a polynomial and it is continuous. So therefore it will be 5 times 2 plus 1, that is 11. And f of 2 plus the right hand limit, and in the right hand limit fx is 1 plus 4x plus x square by 2, limit x tends to 2, it will be 11, and they are equal. So therefore the left hand limit at 2, right hand limit at 2, they are equal. Therefore f of x is continuous at x is equal to 2, and moreover f of 2 is the common value, that is 11. So f of x is continuous at x is equal to 2 and f of 2 is equal to 11. That is the continuity at x is equal to 2. Now let's look at our options. Option 1 says f of x is not continuous at x is equal to 2, but whereas it is continuous, therefore the option 1 is not true. We have that function, and we also have f of x is continuous at x is equal to 2 and f of 2 is equal to 11. Let's now discuss about the differentiability at x is equal to 2. And for this again we calculate left hand derivative and the right hand derivative at x is equal to 2. So f prime 2 minus, that is left hand derivative, this will be limit h tends to 0, f of 2 minus h minus f of 2 by minus h, note down, it is minus h. And f of 2 minus h means this is in this branch, So that will be limit h tends to 0, f of 2 minus h is 5 times 2 minus h plus 1, and f of 2 value we know, it is 11. And simplify, you will get minus 5h by minus h, that is 5, limit h tends to 0. And f prime 2 plus the right hand derivative in this one, in this branch, limit h tends to 0, f of 2 plus h minus f of 2 by h. And f of 2 plus h means in this branch, it will be 1 plus 4 times 2 plus h plus 2 plus h whole square by 2 minus f of 2, that is 11. And now 1, 4 2s are 8, you will get, and 2 square by 2, that is 2, that is 11. 11 minus 11, 0. And then you will get 4 times h, and 2ab, 2 into h, that is 4h by 4 by 2, that is 2h, and h square by 2, whole by h. As h tends to 0, it is 4 plus 2, that is 6. And what do you observe? Left hand derivative at 2 is not equal to right hand derivative at 2. Therefore, f of x is not differentiable at x is equal to 2. Thus, f of x is continuous at x is equal to what we have seen in the previous slide. And now we have seen f of x is not differentiable at x is equal to 2. So let's look at our options. The option 3 says f of x is continuous but not differentiable at x is equal to this, right? So that is, therefore, the option 3 is true. We are also saying the option 4 is not true. Why? Because it is not differentiable at x is equal to 2. So our answer is option 3. That is, f of x is continuous but not differentiable at x is equal to 2. That is the discussion of the solution of the problem from the section Differential Calculus, and the problem is on continuity and differentiability of a given function. I hope that you have understood the solution of this problem. I wish you all the best. Thank you.